some training on how to complete the square for a given quadratic expression, and then using complete the square to solve a quadratic equation. The good news is you've done complete the square at GCSE in your last school, possibly since you're 8 or 9, but most likely just at the end of year 10, beginning of year 11. The good news is completing the square is a whole lot easier than it was made out to be when you did it at GCSE, and I'm going to show you how easy it actually is. The even better news is that you're pretty much guaranteed to get questions that look like this, where you have to complete the square, and you'll get 3-4 marks for doing it, maybe more. The complete the square questions start off with a quadratic expression in the normal way, like we've got here, and ask you to rearrange it to a different form. And the completing the square questions, you won't be able to factorise them. Yeah, this does not factorise. There are 8 factors of 7 which add up to 5. There aren't factors of 1 which add up to 4, and so on. So you need to get good at these, and you will, because it's not hard, especially the way I'm going to show you. The slightly bad news, as far as some of you are concerned, is that at A level, I can't remember any time, any question from any paper where you got credit for using the quadratic formula. The formula is easy. And we can actually use the calculator, and we'll show you later on in the year, as you do A level, we'll show you quite a few ways to use the calculator to do these kind of processes, such as use the formula to solve a quadratic equation. You don't even need to know the equation anymore. You just put an A, B and C into your calculator, tap a couple of buttons, and it gives you the roots. But there's no credit on an exam for doing that. You will need to demonstrate that you can use the process completing the square. I think I've solved it. I think I've given you the motivation to learn how to do this. Right, let's have a look at this one. X squared minus 4x plus 1. We've got to put it in the form of x minus a all squared plus b. Right, the process is really simple. We halve this number. We put it inside the bracket with an x. So that's going to turn into x minus 2. There you go. Halve the 4, put it inside, or minus 4. Halve of minus 4, that's really hard, isn't it? Put it inside the bracket with an x. It's really hard. Square the bracket, it's getting even harder. Square this number, which is 4, and take it away outside the bracket. And then the other bit, just copy it down. And then the next line, just simplify those two bits that you just did. So we get x minus 2, all squared, take away 3. Hard? Don't think so. Should we do it on this one? This is slightly more difficult because there's a fraction. Really? You're an A-level student. Fractions? Doddle. Right. Halve the 5. Leave it as a fraction. 5 over 2. Yeah. I know lots of you will love decimals and think you've got to decimalize everything. No. Fractions are king. Pretty much everywhere in A-level maths. Leave things as fractions. Top heavy. Even with a third as a denominator, it's fine most of the time. So we've halved the 5, put it inside the bracket with an x. It's really hard so far. Not. Square the bracket, square the fraction. That's why we leave it as a fraction, because to square a fraction is dead easy. Square the top, 25, square the bottom, 4, and always take it away. Add the 7. This is ever so slightly more difficult. Turn the 7 into a fraction to match the denominator you got there. So that's going to be 28 over 4. 28 over 4 is the top heavy way of writing the 7 so that the denominator here matches the denominator there. So on this line of working, we've done a lot of steps, haven't we? What have we done? We've halved that number, put it inside the bracket with an x. That's 2 things. We've squared the bracket, 3 things. We've squared this number, 4 things, taken away 5 things, and then we change that to a fraction to match the denominator that we've got here, 6 things. The next line is to simplify the fractions that we've got there, but we've just made it easy for ourselves because how easy is it to add 28 onto minus 25 and get 3/4? Yeah, add 3/4. Pretty simple, right? 6 steps, but nothing hard about them. Okay, one more step when we've got more than 1x squared. And the first thing that we do there is to take 5 out as a factor of all these terms. So we're going to divide all these terms by 5, but then multiply by 5 on the outside of the bracket. So 5 divided by 5 to leave an x squared. Take away 3/5 of x. Take away 4/5. Okay, so we've got fractions happening in 2 places, probably. Whatever you're given. In this case, it's 2. All right. Okay, so this is the bit where I differ from book methods from other people's methods, but you'll see this method in my madness, if you like. Yeah, what we do next is to solve something like this, where we do exactly the same process, but we simplify ever so slightly. So doing this is harder than when we solve. Right. Kind of leave the 5 there, but forget about it for a bit. Yeah, we're going to complete the square on a quadratic expression inside the square bracket. Complete the square inside the square brackets. Halve the fraction here, which normally means doubling the bottom. We're going to see an example here where we can halve the numerator, half the top. So this becomes 3/10 by doubling the denominator. Halve the fraction 3/5 is 3/10. We square the bracket, square this number and put it outside the bracket and take it away. So it's 9/100. And this is the ever so slightly more difficult bit, because you've got a fraction there already, and we need to turn that minus 4/5 into hundredths. So we know we're going to stick with a minus. What have we done to 5 to get to 100? Times by 20. So what do we do with the 4? Times by 20. All right. Again, we've done 6 parts, 6 different little processes. First one, halve that number. Second one, put it inside the bracket with x. Third one is square it, square the bracket. Fourth one is to take away and the number, this fraction squared. And the 6th thing is to turn that fraction in the same denominator as this one. What we're going to do next is 2 things. We're going to put these fractions together. Well, that's not very hard because we've just made the denominators the same, so that's really simple. And then multiply everything by 5. So this bracket becomes 5 lots of the bracket, squared. Take away 89/100 times the 5 means that we cancel the 100 down to 20ths, and we've got minus 89/20. Right. In 3 lines, the first line is dead easy. Take a factor out, and the factor is always the number of x squareds. Leave the rest inside a square bracket to help you remember that we've got to complete the square in the square bracket. We do 6 steps, none of which is really nothing hard. In fact, they're really simple. Halve this number, copy it down essentially, just double that one. Leave it in the bracket with x, square it. Square this number, always take it away outside the bracket, and then turn that fraction in the same denominator as this. The last thing, just to rearrange it, make it look nice, put it in the format that's required like this, is to multiply everything now by the 5. But first of all, we want to put those 2 fractions together. Well, we just made it easy by leaving them like that, look. All right, this one. Made it slightly sneaky because the x squared term is this one. So I've got minus 6 now. I've got a minus x squared. So minus 6 comes out the bracket. When we divide all our terms by minus 6, we've got x squared. 8 divides by minus 6 to leave 4/3 when I've cancelled it down, but that's not very difficult to do. And minus 1 divided by minus 6 is plus 1/6. Okay, so the minus ones, no one likes minuses, me included, but here's a way to deal with it. We take it outside the bracket. Inside the square bracket is the bit that we're going to complete the square on. What do? Leave the minus 6 on the outside, kind of forget about it. Put x with half this fraction. Well, we can, the top look is even, so halve it. Don't double the bottom and make 4/6. That just, Makes it harder. Right, this is a difficult version though of completing the square, and you'll see why now. When I square this number, I get 4/9, and I always take that away from this bracket. Well, that 9 and these 6 don't match very easily, but it's fractions. It's really never going to be that hard, but it's just a bit clumsy. What I do is cross that out and make it 36, so the denominator is going to match the one that we've got here. To make 9 into 36, I've got it times by 4. So the top becomes -16. Turn this into 36 means multiply by 6, which means the numerator becomes 6 over 36. Right, I've prepared ready for the next thing which I'm going to do, which is to put these two fractions together. And then I'm going to multiply everything by -6. So the first bit is nice and easy. -6 lots of x minus 2/3 squared. Take away 16, add 6 becomes take away 10/36. But when I multiply by minus becomes plus 10. And the 6 and the 36 cancel to leave 6. Well, this is fine. We can cancel it down, and that's fine doing it like that. Whenever you cross something out to adjust it, make sure that you do a nice neat line so you can see, examiner can see, I can see, anyone who wants to look can see what was underneath there that you crossed out and replaced it by the 5/3. We're not replacing the plus, so that we've completed the square. There's 4 examples. Those are 4 types of things you're going to have to do. Let's recap. Easy peasy. Even number. Halve it, put it inside the bracket, square it, square the number inside the bracket, take it away outside the bracket, another 1. Halve it, put it inside the bracket with the x. Slightly more difficult because it's a fraction, but leave it as a fraction so that we can square it nice. This one, we need to make it the same denominator, and then it's dead easy to add when we've got a coefficient of x squared. So non-modic, always more difficult. 1 extra step. Look, we've got 2 lines, second line is the answer. 2 lines, even when it's odd, second line is the answer. This one is 3 lines, but the first one is nice and easy. The difficulty is about these fractions, especially when the first denominator does not match the second one. Okay, let's see what we do when we solve. And you'll see completing the square and solving is just as fast as completing the square. With some practice, it's way faster and way easier than using the formula. So what do we do? Well, we've got 4 examples here again. They're exactly the same as we just did. We're going to complete the square, and in 2 lines we're going to get the answer. Both of the answers which solve this quadratic equation. So what do? Halve this number, put it inside the bracket. It's exactly the same as we did before. Square this number, take it away outside the bracket. Exactly the same as we did before. And then add the 1. It's already there and it's equal to 0. Okay. Where before we pretty much got the answer now by putting them together, we're going to do it just a little bit more and we're going to get the answers. So these two go together and make -3. We're not going to write it down though, not there. We're going to take that -3, put it over the other side of the equal sign, get rid of the 0 and put the +3 there. Get rid of the square sign by square rooting and make sure we get the plus or minus version in. And then the next line is the answer. The only thing that we've got left with the x is that -2. So we're going to bang that over the other side as well. Technical phrase, bang it over. Right, x equals 2 plus or minus square root 3. All right, is that final answer? Both the roots. And just like when we use the equation, we got a number plus or minus the square root of something, sometimes divided by a fractional. Yeah. This one, exactly the same. Just like we did before, complete the square by halving that number, put it inside the bracket with x, square in the bracket, square in the number, leave it as a fraction, makes it nice and easy to square. This won't solve, and you'll see minus x, so change it to a +3, so that becomes +12 over 4. So we match that fraction to this one, just like we did before. Slightly more work to do than we did here. Equals 0, but like we did here, we put those together and get minus 13 over 4. We're not going to write it there. Technical phrase again. We're going to bang it over this side and change the sign. So the minus 13 quarters became plus 13 quarters. And you can see if that was 28 over 4, this would give us a plus number, which would then become a minus 3 quarters, and we can't square root that. But that's by the by. It's not 28, it's 12, because we're solving a different equation. Yeah, than the one we started with. Let's square root it, make sure we get plus and minus, and move over the 5 halves. And so we get x is equal to minus 5 plus or minus the square root of 13. Square root of 4 is 2, which matches the denominator we got there. And there's our answer, which looks like the answer that we get to using the formula. And with practice, it's nice and simple. When it's not 1x squared, this is where it gets a little bit more difficult using the formula. What we're going to do is divide everything by 5. Probably wouldn't write this. Don't waste time. We need to put these two together. So that becomes minus 4 is equal to 0, and then the fifths. So we got rid of that thing too. The next line is what I would write down usually. X squared minus 3x over 5, take away 4/5 is equal to 0. Okay, so that would be my first line of work in. Wouldn't bother with this divide by 5 thing, because we know what we're doing there. That was just to demonstrate what we're doing. Okay, so complete the square by halving this number put inside the bracket with x. Square the bracket, square this number and take it away outside the bracket, which becomes hundredths. Match this fraction with the denominator that we've got there. So we've got 2 times by 20, so it becomes 100. It's a minus fraction. Because we times the 5 by 20, we're going to multiply the 4 by 20 to get 80 equals 0. Put these two fractions together, bang it over the other side, square root it, and then add the 3/10. So x equals 3/10 plus or minus the square root of 89 over the square root of 100, and there's our answer. Easy peasy. And if you want to, we could write it as 3 plus root or minus root 89 over 10. This one, because it's not in the right order, and because we've got a minus, I would probably spend a moment rewriting it like this. I'm going to change all my signs when I rewrite it. So that's a plus, this is a plus, that's a minus. Rewrite it and then divide by 6. So 6x squared, take away, that's a plus now, take away 8x, add 1 is equal to 0. Divide everything by 6. I'll put that in there, I wouldn't bother writing this. X squared minus 8 over 6, which is 4 over 3, and then add a sixth is equal to 0. Half this number put inside the bracket with x, minus 2/3. Square this number, square the bracket, take that square away, 4/9. This is where it gets a little bit more complicated when we divide by a number. Sometimes it didn't over here, but it has on this one. We've got a different denominator here than we have there, and it's not as easy just to change like we did here. We just changed that one, we left that to 100, we changed that one to 100, nice and easy. This one needs to become 36, and it's minus 16 of them, so that we can match that sixth that we've got there, and that's a plus, wasn't it? So this becomes plus 6 over 36 equals 0. Put them together, move it over to the other side, 10/36, square root it, plus and minus it, and then add the 2/3. X equals 2/3 plus or minus the square root of 10 divided by the square root of 36, which is 6. And that's why I didn't simplify this 10/36. We could have written it as 5/18, but 18 doesn't square root in as easy as 36 does. Right, this is the slight difference from using the formula, because we've got different denominators here. X equals 4 plus or minus root 10 over 6 if we want. That's the same by doubling that to get the same denominator here, which means that we double the top to get 4. Right. Let's do a question which we'll just make up on the cuff, and I'll just demonstrate so that you go ahead of the game when you're going to solve some of the sets of questions that you're going to do next. Right. If we had 7x squared plus 5x minus 1 equals 0. And we're going to solve this by completing the square. First line, x squared plus 5 sevenths x, take away a seventh, equals 0. Halve this number, x plus 5 fourteenths, square it, minus 25, 196. This becomes take away 49 over 196. Does it? 28 over 196 equals 0. Put them together. It's 53 over 196. Square root it, and then add the 514, and take away the 514. So x is equal to minus 5 plus or minus root 53 all over 14, because the square root of 196 is 14. And in 3 lines, pretty much guaranteed. 2 lines if we haven't got a number of x squared, if it's just 1x squared. 3 lines if we do have a number of x squared. The first line is easy, piece of cake.